Scientific notation is a way to write very large and very small numbers in a very compact fashion. It's also less ambiguous to write some numbers in scientific notation, because remember, a zero can be a significant figure or it can be a placeholder zero that just shows you where the decimal place is. So when you write something in scientific notation, if a zero is a significant figure, you write it down, but if it's a placeholder zero, you leave it off. So scientific notation relies on this trick, that if you write down 10 raised to the power of some number, you start to see the following pattern. 10 raised to the power of 0 is 1. 10 raised to the power of 1 is 10. 10 raised to the power of 2 is 100. 10 raised to the power of 3 is 1,000. And 10 raised to the power of 4 is 10,000. So this is a very compact way to keep track of powers of 10, because if you've got 10 raised to the power of some number x, it's always going to be 1 with x zeros after it. So as I said, scientific notation is for writing really big and really small numbers in a very compact fashion. And this is good because astronomy has some very big numbers. So here's one. This is the speed of light in meters per second. To write this in scientific notation, the first thing we want to do is locate where the decimal point is. And it's located here at the end, and now we're going to count how many spaces over we have to move it to put it right beside the 3. So 1, 2, 3, 4, 5, 6, 7, and 8. And so to write this in scientific notation, we write 3.00 times 10 to the 8, where the 8 is because we moved the decimal point 8 spots over. And by the way, the reason why we have 3.00 written here is that these two zeros are significant figures. That's the correct accuracy for the speed of light. The other zeros were just placeholder zeros. They just told us where the decimal point fell, so we left them off. So now let's write a very small number using scientific notation. Again, we start by finding the decimal point, and then we count how many spaces over we'll have to move it to put it right beside the 1. So here's our decimal point, and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so we would write this as 1.84 times 10 to the negative 12, where it's negative 12 because we moved the decimal point 12 spaces in the other direction.